Good evening, everyone. My name is Manyatam Prakash, and welcome to the week 8 on problem solving session for industrial wastewater treatment. The course instructor for this subject is Professor Alok Sinha and Professor S.K. Gupta from IIT Dhanbad. So, as usual, we meet every Tuesday from 6 p.m. to 8 p.m. and the link for online meeting are regularly shared with you, and the recording of this session is also uploaded on this YouTube channel, the link for which has been also been shared with you. Hmm. In week 8 of industrial wastewater treatment, we are dealing with tannery and pulp and paper industry. This tannery is separate industry and pulp and paper is individual industry, kind of like tannery we deal with the leathers, and here in pulp and paper we took the pulp. I think everybody is aware of pulp. So pulp is a fibrous material, is generally from the wood or it's like uh, for in with respect to paper, if it pulp can have many definition, okay na, but if we talk with respect to paper, then generally the fibrous material in the are from the wood, and wood is refined, furnace, and then we got our, what do I call, mm, paper, okay now. So there are four process which has been already been discussed in your online lecture. So as usual we will have a five, I will be recapping in 4 to 5 minutes. I would be taking, and after that we will have question and answer, where I will ask everyone to please participate. So I don't, very few had joined, only two people had joined. So I will be going little bit slow, so that mm, I don't know why no one is joined. Huh? So tannery, simple tannery, like tannery deal with leather, okay na. So why this is concerned? The concern is because see, when we take our this thing leather. Just a minute. See, if you generally animal skins are used as leather, okay now. So what happened that when it is removed, when those are collected from animals, then those are very soft, okay now. So now is it soft, and you have to make it in some kind of shoe or belt, okay. So you have to make it hard, okay now. For that they use something called basic chromium sulfate, okay now, where this chromium is in the form of plus 3, okay. So what happened that they use this basic chromium, that is basic chromium Cr2SO4 whole thrice, something kind of this, okay now. There might be different formula also. So they use this thing, and now imagine that if you are using it, a part of chromium will washed away with the water, okay now. So this is mixed in water, and on suppose this is your leather sheet, so it will be sprayed all over this part, so it will make it hard. So in doing so, a water will be used, and this water will be drained out, okay, and this will be a wastewater, okay now. So now initially chromium 3 salt was used, okay now. So what will happen that when once it is in water, it will come in contact of oxygen, and it will convert into chromium 6. Chromium 6, this chromium 6 is very carcinogenic in nature, okay now. Carcinogenic means cancer causing. There is a cancer causing, okay. So so generally it is suggested that there should not be any chromium. So that's why any tannery industry, around the tannery industry, the whole area is this affected by this chromium problem. Okay na? So there are several near Kanpur. There are several location. One of the famous location is Rania. Okay na? Rania or Kanchandpur we say. Okay na? This is highly affected by this chromium contamination. And not only wastewater. Okay na? So now see this in tannery industry, this is used in the form of salt. So all the salt are not, this is not completely dissolvable salt. Some part will remain. Okay na? So once it is just sprayed over this leather thing, this skin animal fur. So it is one part means some part is getting converted into water also, that is getting dissolved, that is forming wastewater. And some it will remain in the solid form. Okay na? And that is known as COPR. Okay na? COPR. COPR. Okay na? Chromium ore processing residue. So what will happen that this thing, the salt which was unreactive or unused, so it generally it is dumped in a, there is a province that it should be dumped in a proper, with proper management, all this thing. But for I'm saying the example of this location Rania. So consider that this is a main road. Okay. Oh, sorry. Let me rub everything. And yeah, what has happened in this town now? I will show you. So this is consider this is a highway. I think which highway? Lucknow. I don't remember the, but it is Kanpur connect something from Kanpur. If you go either to not Lucknow, but either to Prayagraj or okay, I don't know that thing. Okay, no. So there was around 90s, 90, between 90s to 2005. Okay, no. So what happened that there was this a open site here. So and there were many leather industry, small. So what happened that they all dumped their this COPR. Okay, now after treating their treating their leather, they all dumped their waste here. So what happened that now initially it was the chromium was in the form of chromium 3. So with time what happened that rain occurred, so and there was oxygen and all these things. So what happened that this chromium 3, in presence of rain, what happened that this chromium which was 3 started to percolate in the groundwater, and the direction of groundwater is in this way. Okay. And this part, this is a, see, the Rania is a big part, but here there is a village known as Kanchanpur. Okay na? So now what happened that this chromium percolates in the groundwater, where it get converted into chromium 6 in the presence of oxygen and rain. And with time what has happened now, if you visit this village currently, and if you dug say maybe 5 feet, 10 feet, 20 feet, you will get a greenish water. Okay na? Greenish water, that is due to high amount of chromium 6. Okay now, at the end of the lecture I will show you how, miss, I have those pictures. Okay now, I will show you how does it look. And if you visit this site now, you will see that all the lands are yellowish, greenish, yellowish, greenish, greenish yellowish, something kind of shade. Okay now, this was another, this was related to, in tannery industry, this is the like problem due to solid waste management. Okay now there is a problem with wastewater also. I will share you one story. It will take few minutes, don't worry. Okay now, there is one more, there is one this Jajmao in see, I'm sharing this story because this incident, because I am in Kanpur, and this Kanpur is famous for leather industry or tannery industry. Okay, na. So if you visit this Kanpur, you will see many tannery industry, and many people are studying this chromium problem. Okay, na. I have also worked in related to chromium. Means I have developed one filter which treat chromium. Okay, na. So the and I have installed this filter in this Kanchanpur, because this Kanchanpur, they are dependent upon this tank water. They don't have their own. So from my lab, we have developed one filter that was able to treat around 15 liter of drinking water, this chromium contaminated water at once. Okay, na. So if time persists, I might so, but but another portion is this Jajamao. Okay, na. So what happened that this is Jajamao power plant. Okay, na. And what happened that from here a treatment plant, a canal is constructed, and the treated water is passed through it, and it is then this canal is sorry, then this canal is uh, then this canal is used for irrigation purpose. Okay, na. So what happened that this part of this water treatment plant was to, so see here there is many industry, they all are dumping their chromium contaminated wastewater here. Okay, na. So the purpose of this treatment power plant was to treat this chromium. Okay, na. All the chromium should be, it should be very low. Okay, na. I think the number is 50 mg per liter. It is in drinking water. I have to see what is the permissible limit in channel. Okay, na, for irrigational purpose. But for drinking water, it is 50 microgram per liter. But for irrigational purpose, it will be also around this thing only. Okay, na. But this treatment plant failed to do this thing, and the treated water which is passed through in this canal contain huge amount of chromium, and that water is used for irrigation purpose. On for from those water they produce rice, mustard, and all these things. So if you take this rice and all these things now, you will find chromium in that water, in that rice. So there are many things. Okay, now, so that's why a proper treatment overall, I want to say that a proper treatment plan should be there, because see, treatment plant have their this agenda or aim now, that we want to treat in such a way that water can be reused. Now the aim of this treatment plant was also this thing, that we want to reuse the treated water. Okay, but you can see that in doing so they are damaging more to the environment, because here now this rice will be eaten by, and not only this thing rice, now what is happening, that some part of say due to infiltration and all this thing, sometime what happened that some, suppose if you visit any village and there are 4 5, suppose 10 borewell, so there are high chances that out of 10, one borewell may be contaminated with chromium. Maybe, no, I'm not sure. It might not be. But the river canal which is flowing through beside those river na, contain high amount of chromium. So that is carcinogenic for this animal also, human also. Okay. So that's why we have to take proper care for its treatment, or else everyone will suffer. Okay, so here I am seeing that saying this thing, that tannery wastewater into tannery tanning industry converts animal hides. Hides means a skin. Okay, na, into leather using chrome or vegetable tanning. Generally, this vegetable tanning is different thing. Whatever I was saying about this chrome tanning, that is sheer chromium. Tanning wastewater contain water polluted with color, BOD, dissolved salt, and toxic chromium. Okay, na. High BOD, why? Because this is animal hide or animal skin, which will contain high amount of organic matter. I hope you are getting it. Okay, now dissolved salts due to dissolution of mhm, basic chromium sulfate. Okay, now I'm not writing the formula, but due to this high amount of toxic chromium, because this chromium which is the in salt which has been used contains chromium, it will leach out chromium, so a high amount of chromium will be also there. Tanning process involves preparation of hides or preparation of skin, soaking, liming, deliming, wadding, picking. These are different processes which has been already discussed. Tanning, most common, and vegetable tanning. Fishing is finishing, culling, softening, drying, and embossing. These are some of the process. Okay, na. Wastewater contain high BOD, COD. We have already ammonia, sulfide, chromium, and a strong color. Okay, na. Cause severe water pollution, oxygen depletion, fish toxicity, soil contamination, and sewer clogging. Why this happen? Because a huge amount of organic matter is there, so it will consume all the oxygen. Okay, na, high organic matter, so it will consume all the oxygen, and the condition the DO will be low in the river or canal. The fish will die. Okay. Then there are different treatment method. First is the screening, remove the solid. These are some chemical correlation with alum or ferric chloride or color chromium or chromium and beauty reduction. Biological treatment, activated sludge process is there. Then trickling filter is there. Then anaerobic lagoons are there. What is the purpose of these different treatment units? For that, I will suggest you to please go to the lecture notes. Okay, na? Now second part is pulp and paper industry. Pulp means paper, pulp and paper. Pulp is very common term, but when a and paper is done, you have to be cautious that which kind of pulp they are talking. So generally they are talking about wooden pulp. Okay, na. So one of the oldest and water intensive industry generating high amount of high COD and colored wastewater. Remember there here there will be no this BOD because there is no organic matter and all these things. Here we are just there will be wood, so that will be cutting and like sorry, organic matter will be there, but biodegradable organic matter won't be there. Okay, na. See, this COD consists of all the organic matter, that is biodegradable, non-biodegradable. BOD only talks about biodegradable organic uh, matter. Okay, now the one of the oldest high pulp manufacturing, mechanical pulping, physical separates fiber used for nutrients. So they will, suppose there is a wood, it will section will be cut, it will be brought in the factory, and a fine fibers will be made. Okay, now chemical pulping is there, then chemomechanical. These are different method of pulping. Contain lignin, chemical resins, fatty acid, and suspended solid. You can see that they have amount of different type of what. Can anyone say what is lignin? Anyone? Anyone know what is this? Contains lignin. What is lignin? Anyone? You must have gone through the lectures, no? Anyone? It's kind of a polymer. Okay, polymer. Yes, good. Polymer of cellulose. Good. So, so a special type of treatment has to be done. Okay, now treatment method, you can say recovery, fiber remove to reduce pollution, clarification, flotation, and these are some of the common. Then chemical coagulation, activated carbon lime treatment for color removal, and all these things. Okay, now biological, as it contain high amount of cellulose, then we have to aerated lagoons. Aerated lagoons is like open type of system. Wastewater will be added, and mechanical aeration will be done, so that organic matter gets sufficient amount of oxygen, and it can degrade. This bacteria can get sufficient amount of oxygen, and or there are many reason. I'm saying one of the those reason. Okay, now aerated lagoons have many advantage and everything. Then we have advanced treatment and all these things. Okay, now and see element restriction. So for if you have gone through the lecture, you must have seen one thing that if- depending upon where you are staying, there will what happened. Hmm. Where like where you are throwing your wastewater, treated wastewater, there will be certain limit pH. So generally there are four parts. Either you can throw on land or river or slash lake, ocean. Okay, na. So for all these four, we have certain limits. So the water which is coming from the treatment should meet those standards. Okay. Similarly, was there was and what are different condition, like you can always go and check in your video lecture. Okay, na. So from next on, what we have, this was a small recap. So before going to question and answer, does anyone have was having any assessment problem in week 7? Any assessment problem in week 7? No. Okay. Then coming to this lecture, in chrome tanning process, which is the following chemical is used? Very easy questions are there, and if you have gone through the lectures, one thing is to note that all the questions this time, all things were theoretical thing, no numerical thing is there. A No, A is not correct answer. See, this thing is, this chromium 6 generally don't exist normally. Okay, now it exists, but in presence of oxygen and all this thing, it get oxidized and it form chromium 6. So the chemical which is generally used, that is COPR, basic chromium sulfate, basic chromium sulfate. This is basic salt. This is the salt which is used in the tanning industry. Okay, now here the chromium is in three form. Okay, now so the correct answer will be the B. The trivalent chromium chrome tanning is widely used method in tanning industry where the chromium trivalent compound, particularly basic chromium sulfate (BSC), are used to tan hides. Okay, now this provide leather with high durability, flexibility, and resistance to heat and water. Okay. So remember, hey, this salt is used, and this salt here, if you see the formula and all this thing, you will find that chromium is in +3 form. Chromium 6 is a toxic and carcinogenic, but it is not used in tanning. However, improper handling of trivalent chromium during the tanning process can lead to oxidation of chromium 3 to converting into chromium 6, which is an environmental. And this happens also. Okay, now this chromium 3 always get converted into chromium 6 because huge amount of oxygen is there, condition become favorable, and they can convert. And the problem is very serious. You have no idea if you have not gone through this chromium thing. Yes, I can guarantee you have no idea like what's how huge this problem is. Okay, now remember, when I used to go to sampling, when we pump out any water hand pump, we see that a green water is coming, and see those they are the people residing in those villages know that this water is very bad water. Okay, na, but still someone have don't any option to go for alternative source. And I have seen some cases there are people who directly drink this water, and they complain that after drinking water they just vomit. Okay, now, and as it is carcinogenic, it this thing won't reflect immediately. Okay, now, it will take some time. Maybe after 5 year or 10 year, you come out to know that the person who was drinking this water is suffering from cancer, and or he may die also. Okay, now option C was this thing, extract of warts. Its name itself suggests that it is related to this. It is related to paper wax and then so it's not related to this thing. Okay, so the correct answer was B. I hope everyone has got this thing. This is simple question, no explanation needed for it. During the liming process in the tannery, the hides are treated with a paste of lime sodium sulfide, which are in the ratio of anyone. I request everyone please participate. Can anyone answer? Okay, no problem. A 1:4. Nope. The correct answer is D. In liming process of tanneries, hides are treated with mixture of lime, that is calcium hydroxide and sodium sulfide to remove the hair, fats and unwanted. Typically, the ratio of lime to sodium sulfide are used in this process is to 1. Okay, now if you go to the if you go to the lecture notes, you will understand this why this 8 point. It's optimized thing. Okay, now so adding this much does not count any secondary pollution and all this thing. Okay, now and it also helps in the removal of hair, fats and unwanted protein. Okay, so those who were saying A11 people, please, I request you to please go to the lecture. Okay, now there you will, if you see all these questions are directly from your notes. Okay, role of fish. What is the role of calcium hydroxide? Swells the hide, making it more respective for further processing. Helps in breaking down keratin, that is hair. Increase the pH, maintaining the hide alkaline, easier to process. Okay, na? Can anyone say how this calcium hydroxide increase pH? Anyone? I will just write it down. So see, if you write down the reaction, CH whole twice plus H2O. So what will happen that uh, suppose how can so if you write the reaction now you will see that a huge amount of H plus is getting consumed. Okay, now for its dissolution. Okay, now so suppose if H plus concentration is decreasing, so obviously OH minus concentration will be increasing. In that sense, the pH will be also increase. Means OH minus concentration is increasing, H plus is decreasing, means pH is increasing. We know that pH barabar minus of log H plus. Okay, what is the purpose of sodium sulfide? This work as a deherring agent for breaking sulfide bonds in keratin. So it is generally used for removal of hair and all the thing. Acts in removal of proteins and unwanted tissue. Using 8 is to 1 ratio lime to sulfides ensures sufficient deherring while maintaining the duty quality of hide. A lower lime content would result in significant swelling and too much sodium sulfide could weaken the hide structure. Okay, now so the optimum value is it is to 1. Any doubt in this thing? So the correct answer was just I think Nayage you have said A, that is incorrect. Your correct answer will be D. Hmm. Another question is there. Which of the following statement are true for a spent liquor produced during leather production industry? I think I will go with the answer, or should it, is anyone trying this? Hmm. But I don't know. What is time? It is 32. Okay, no problem. No problem. I will be showing the answer. The correct answer is 236. This 2, 3, and 6. Okay, now. So we will see how. Wastewater tannery is classified into continuous wastewater, mainly from the washing, and intermediate wastewater, mainly from the spent liquor. Okay. Spent liquor are the most polluted part of tannery wastewater, contain high concentration of BOD, COD, sulfide, ammonium, and chromium. Some liquors form a smaller fraction of total wastewater, whereas wash water make up the fraction large. Okay. So, if you want to answer this question, first you have to understand what is this spent. Okay. So, a kind of wastewater that it is a particular name given by these people. It's like this spent. Okay, no, but it is a kind of a wastewater containing high amount of BOD and COD. Okay, na. So the first we will look into the correct answer. That is intermittent. What is this thing? Hmm. So sorry. Where did it go? Hmm. So this thing which we have already seen, that there is intermittent wastewater. So this is correct. Okay, now so spent liquor are generated intermediate from the process like liming, picking and tanning. Okay, now if during this process, this a huge amount of wastewater is produced, and that is considered as intermittent wastewater. This means they are released at a specific time but not continuously. So I think hope you have understood. Okay. Highly polluted. Yes, this is correct. We know that we have seen also there are uh, like if you have gone to we have seen what I mean to see that if you have gone through the lecture you have missed there. It has been discussed that how how contaminated and how high amount of BOD and COD generally. So, see, high amount of BOD and COD is only due to presence of this organic matter present in this fur and all. A small fraction of wastewater produce spent liquors are highly concentrated but make a small fraction of wastewater which are continuous from majority of tannery effluent. So means, these are in a simple word these are very concentrated form of wastewater may contain high chromium. Okay na, high BOD, high COD. Okay na. Okay. So this is also correct. And why others are incorrect? Continuous, this is incorrect because the spent liquors are not continuous, they are intermittent released in batches. Continuous refers to the wash water which is not polluted. Okay na. Wash water is, see, try to connect it everything. This wash water or simple vac wash is also there. Many, if you are understanding what is this wash water, it's okay. If you're not understanding what is this wash water, you can consider as a back wash and all these things, but these are generally not polluted. Okay. Less polluted, we have seen that this the high amount of chromium, high amount of BOD, we have already seen this thing. uh, hmm. 6 was already correct. Okay. So the correct answer for this was, if anyone have any doubt, correct answer is B, 236. Anyone have any doubt? Please ask now, or else we will move to second question. Fourth question, sorry. Which unit operation produce wastewater containing formaldehyde and solvent during the leather manufacturing process? Try to answer it. Anyone, those who have joined, six people are I think five people are there. I request everyone to please participate, and you will be able to participate only if you have gone through the lectures. C, finishing. Yes, finishing is the correct answer. Good. Leather manufacturing different unit operations generate various pollution. The finishing process is the stage where formaldehyde and solvents are used. Okay, the finishing process include stuffing, fat liquoring, and dyeing and coating to give leather its final property. So this is final finishing itself suggests that now everything work has been done. Now time to finish. Okay, now so during that time this formaldehyde and all these things are used. Okay, now synthetic dye, resin, formaldehyde waste, fixatives and organic solvents are commonly used in this stage. Okay, these chemicals enter the wastewater stream, making fishing one of the key source of solvent and formaldehyde contaminated in tannery industry. Okay, na? So this finishing wastewater, after finishing, what will happen that a high amount of this thing will be there. What do I call? What is it? Okay. Synthetic dye and all these things. So what will happen that it will just consume all the oxygen present in the wastewater. So now there is no huh, so means now this formaldehyde and all these things have have certain what do I call, what do I call, I am not remembering the what is the this what the this solvent does, but it has very like not it's very unwanted that we don't want our wastewater to contain high amount of formaldehyde and all these things. Okay, now so that's why after a huge amount of these things are released in the wastewater, and we have to treat those wastewater. Okay, now liming, incorrect liming is used to remove. We have already seen liming and NaH2. Okay, then other option was soaking. Soaking rehydrates the hides and remove dirt using mainly water and salt. Here also. Then there is batting. Batting is done using enzymes to soften hides. Okay, now the wastewater contain proteins, ammonia, and enzymes, but not for all. Tanning is there. Everyone is aware of tanning. Tanning use chromium salt or extract to stabilize collage. Yeah, to we have seen what does this chromium does. Okay, now the wastewater contain chromium tannin. Okay, question number fifth. Ferrous sulfate is not used as a coagulant during the treatment of vegetable tanning water due to which of the following reasons? It might be single correct and multiple correct. Anyone? Any answer? Anyone? Okay, no problem. This ferrous sulfate Only the correct answer was this thing, A na, A. Okay, so the question was ferrous sulfate, okay na, is not is not added as a coagulant during the treatment of vegetable tanning, uh, because so see, we will be seeing the regions. Okay, now the ferrous sulfate, that is a FeSO4, is effective coagulant for treating chrome tanning wastewater because it helps in removal of color, chromium sulfides, BOD, and suspended solid. Okay, however, for vegetable tanning, the ferrous sulfate is not used because it intensifies the color rather than remove. Vegetable tanning waste contain tans which react with iron salt Fe2 to form ferrous sulfides and form darker color complex. Okay, instead of ferrous sulfate, LM is used as a coagulation in vegetable tanning after prior neutralizations. So I hope you have understood. Okay, now so generally what happens that when this chromium thing is being done now, so in that case this Fe2 plus can be used. Okay, now because Fe2 plus react with chromium 6 and it forms chromium iron hydroxide. Okay, now I don't remember the exact, but it gets precipitated and the water which is left uh, is treated water. Okay, now that can be used. Okay, so that's why. But in vegetable tanning, see, we have seen that there are two type of tanning. One is this chromium tanning and or chrome tanning, and another is this thing vegetable. Okay, now in case of vegetable they use plant extract to remove this fur or to make this leather soft and all these things. Okay, so so in that case there is no role of color and all these thing. Hmm. However, for vegetable tanning, we have already seen. You can here see that the ferrous which is there will react with the sulfate and it will form a darker color complexes which will eventually affect the results and all these things. TSS is not effectively remove the wastewater, incorrect. So ferrous sulfate can effectively remove TSS, but but the issue with vegetable tanning is that color is in intensification, not TSS removal. Okay, na. So mm, this was the reason why this option is incorrect. Okay, then it is not effective in removal of BOD from the wastewater. This is also incorrect because ferrous sulfate is capable of reducing BOD in wastewater by precipitating organic matter with organic, but its use is divided only due to color intensification here. Okay, and this cannot be answer. So the correct answer is A. It intensify. Why it intensify? Fe react with SO4 and well, uh, Fe react with SO4 and they, guys, are you getting it what I'm saying? Yeah, I think I'm continuously speaking. Actually, I'm continuously speaking because I have this idea of chromium and iron and all these things. The question is, are you guys getting it? Anyone? Why no one is speaking? Yes, not fully. In simple terms, just remember that uh, in simple terms, just remember this chromium. When chromium is in 6 form now, so now it is in maximum oxidation number, so it can reduce. Okay, it can reduce to chromium 3. Okay, now we need a reducing agent, so this Fe2 plus, now if this iron 2 can go into iron 3. Okay, means it is getting oxidized, so this is a good oxidizing agent. Okay, now so we need so it has been, after many study, it has been found out that this chromium 6 when it is reacted with iron 2, they this there is two things precipitate uh, what will happen that this chromium 6 will get converted into chromium 3 because this iron has been converted, oxidize this, sorry, reduce this chromium 6 to chromium 3, and this iron itself will get converted into iron 3. Okay na, iron 3. This will happen in water. And now what is happening, this chromium 3 and iron 3 both have a like complex forming uh, method. Okay na, and in presence of water they will form some co-oxy hydroxide chromium 3 plus Fe3, so ppt. Okay now, so if you add a chromium 6 contaminated water with iron 3, you will get a precipitate will be of iron 3 and chromium 3 and iron 3 in presence of uh, hydroxy. Okay now, so this use of iron sulfate is beneficial in what do I call this chrome tanning. Now there is another tanning, that is vegetable thing. So what happened that in vegetable this thing, this chromium sulfate is not added. Why it is not added? Because you can see here, uh, ferrous sulfate is not, because the vegetable tanning contains the react iron to form so what happened that in present this iron 2 will react with sulfate present in the vegetable, because in vegetable tanning a sulfate waste is used. Okay now, so it will this iron 2 will react with sulfates and it will form a color, darker color complexes. So that's why now see, imagine your wastewater has some light color. Now due to addition of iron it has become dark. Why now it need another treatment? Why we want to do that? There is no need of that. Okay now, so that's why in vegetable this thing is not used. I hope I am try to answer this question. I'm coming in 1 minute. Okay now. A 1, 3 and 5 are correct. 1, 3 and 5. Which of the following statements are true for paper produced from hard wood like this thing in comparison to paper produced from soft wood? Okay na. Is first correct? Paper produce is having high strength. Okay, we will sing one by one. Okay, now the correct answer is E235. Okay, no problem. We will look into one by one. Okay, now hardwood, that is this, and softwood have different fiber characteristics which impact the properties of what paper they property of paper they produce. Okay, hardwood fibers are shorter and fine compared to the softwood fiber, which are longer and stronger. Okay, now so remember, don't go by the name, because see, we are not using direct wood for making paper. Okay, now we are dealing with fiber. Okay, now fiber is being refurnished, and that is getting converted into paper. Okay. Hello. Hello. Huh. So see, the difference you can see here. Hardwood fiber are shorter and finer, but softwood fibers are longer and stronger. Okay, so uh, I can understand why you gave answer A, but you should look into the definition of hardwood and softwood. Okay, now so that's what this will be incorrect answer. Okay, now that this first option will be, because its fiber is, for hardwood the fiber is big, that's why the paper will be have lower strength, so this is correct answer. Okay, have high opacity. Opacity means we can see through. Okay, now so for that I have to see, huh? Different list of variation is correct. Softwood are longer, which makes the softwood paper stronger. Hardwood paper have low tensile strength because it's short. Correct. Opacity refers to how much light passes through the paper. Hardwood fiber are shorter and create a denser and more opaque sheet compared to the softwood fibers. This makes the hardwood better for printing and writing. Okay. So as it is smaller, it creates a denser thing, and the sheets, you can say, that is more opaque as compared to the softwood. So two and three is correct. And fourth one, paper is higher smoothness. Again, the shorter, finer hardwood creates a smoother surface. This improves the printability, like ink absorption, surface texture. Softwood. Why other are incorrect? This is incorrect. We have already seen, because the fiber is big, so that's why this is going to be big. Paper produces having low opacity. This is also incorrect. We have seen. Paper produces having low smoothness. Incorrect. Hardwood actually have high smoothness, not low. Okay, now. Any doubt in this question? No. A spent liquor produced during the digestion process in craft pulping process is usually called. Miss, see, suppose if you are producing some, doing some reaction, adding chemical A plus chemical B in water, so what will happen, that AB, suppose AB precipitate, so there will be some water left out. So that is generally called as a spent water. In case of this wastewater thing, okay, na. The correct answer D, that is black liquor. In craft pulping process, the different type of liquors are used and produced during the different stages of chemical recovery. White liquor used in digestion, a mixture of sodium hydroxide, sodium sulfide, used to break down this this cellulose, that is lignin, and separate the cellulose fiber in digestion process. Black liquor is the spent liquor produced during the digestion. Okay, now you see, every unit will have something will precipitate out or dissolve, and after that, whatever the water is remaining, is known as spent water. Hmm. After digestion, the resulting spent water contain dissolved lignin, resins, hemocellulose, and cooking chemicals. Okay. Then we have uh, so th- hmm. Then this black which is highly colored have a very high organic load. Higher organic load means high COD and BOD. Okay, na. It later concentrated, incinerated, and recovered for chemical uses. Green liquor is intermediate stage in chemical recovery form after black liquor is burned into recovery boiler. Contains sodium carbonate and sodium sulfide. Then we have white liquor regenerated from green liquor. Green liquor is treated with calcium to convert the black into its white for use in digestion. Okay, so these are some of the names which has been given at different unit. Then we have brown liquor forms sulfide pulping, not craft pulping. In sulfide pulping, the spent cooking liquor is called brown liquor, not black liquor. Okay. Combined pulp and paper friction we will elephant is having. Remember miss you can answer it if you remember the process. Okay, na, of whole wastewater treatment. Combined pulp and paper milk effluent. The water coming from this industry will have acidic pH, basic pH, neutral pH, or pH may vary. It's all depend on the type of salt which we used. Okay, now the correct answer is B. That is basic pH. That is pH greater than 7. The combined effluent from pulp and paper mill generally have basic pH due to chemical used in the pulping and bleaching process. Craft pulping, the most common method is sodium hydroxide. You can see sodium hydroxide is used. Okay, now sodium hydroxide is used, so that's why pH will eventually increase and it will become sulfide, means basic. Then second thing is Na2S, which makes the wastewater highly alkaline. The bleaching property further contribute to alkalinity due to some use of sodium hypochlorite and chlorine dioxide. So this is something different, but overall you should remember that as this salt is used, it will convert into basic form. These are all incorrect. Whenever this type of question are asked, just look at the basic and see what kind of chemicals they use. Okay, na. Then you can answer the pH. Which are the following aerators during the treatment of pulp, paper, effluent by. Okay, na. Which type of aerators? Aerobic legumes are. This will be here. Okay, na. Don't worry about it. Don't get confused. Try to answer it. It will be here. Which of the following aerator are used during the treatment of what effluent by aerobic? Diffused, fountain, surface, yeah, cascade. Anyone? No. The correct answer is C. That is surface aerator. Surface aerator are simple. If you have gone through this, I don't know. Whenever in Kolkata, I used to see it, but currently I am able to see any lagoon. No. Aerobic lagoons are used for biological treatment of pulp and paper effluent to remove COD, BOD, and organic matter. Okay. The mechanical surface area are commonly used because they provide efficient oxygen transfer for microbial activity, keep the wastewater mixed to prevent sludge accumulation, or wastewater effective. These are some of the options. Okay, na, which helps for higher efficiency. That's why this this surface aerators are. Okay. Huh. Now question number 10. During the massive lime treatment process, which the following statement holds good? Anyone? The correct answer is A. The lime in first react. The lime is first reacted with colored wastewater. Okay, na. The massive lime treatment process is used to pulp and paper is, is used in pulp and paper mills to remove color and organic matter from wastewater. Okay, like lime. Lime is first reacted with the colored wastewater, where it absorbs the color causing compounds like lignin. These lime sludge, which now contains the door, is then used to sorry now contains color, is then used to re cost designing process to recover the chemical for pulping. Okay na. So what will happen that this will react with the color, and it will forms a cellulose kind of compound. Okay na. And it will come as a sludge, because all the things will get precipitated not, or it will be in the mixture of solid plus liquid. Okay, and that is our sludge. Okay, so this process reported to remove 90% of the color and 40 to 60% of BOD from waste water. Okay, other option, why other option are incorrect? The lime is first reacted with green liquor. Incorrect. The green liquor is intermediate product in chemical recovery containing sodium. This thing which have stay away. So this green liquor has nothing to do with this thing. Okay na. Other option is lime. The lime is first reached with white liquor. If this is incorrect, the white liquor is fresh cooking liquor used in the craft pulping process, mainly containing NaOH and Na2S. It is not involved in wastewater color removal. The lime is the first reacted with black liquor. Incorrect. The black liquor is spent liquor from black liquor is the spent liquor from the craft pulping containing lignin, cooking chemicals, and organic residue. Black liquor undergo chemical recovery operation and not massive lime treatment. So that's why this is also incorrect. Okay, now, all the thing is it does not happen on the first. Hmm. These were some of the objective. There are more objective question, as you might have gone through the lectures, then you have missed video material, then you might have noticed that only till mid sem only. Sorry, what do I'm saying? Hmm. Uh, in your assessment, sorry, not mid sem, in your assessment, if you have gone through only for this part, only theoretical question has been asked. Okay, now I don't remember, but these were all previous year theoretical question. So in last session, someone requested that please give numerical question also. That's why I have taken out some numerical question. So we will be solving it. But before going further, anyone have any doubt? Anyone have any doubt? No. Okay. So try to solve this question. If you, I think, all of you who is attending this session have attended my last session also. Okay na? So similar type of question I have shared last time also. Let's see whether you are able to solve it or not. Last time few of you you were giving correct answer also. So I request this time also, please participate, try to answer it. A paper mill discharge this much of wastewater with BOD concentration of 50 milligram per ml. Regulatory limit is 30 milligram. If activated sludge process remove 90% BOD, has a removal efficiency of 90%. Calculate the BOD load entering the treatment plant, removed BOD and the BOD concentration in the treatment. Another question can be, fourth question can be, uh, uh, fourth question can be, what can be? It can be that, does it meeting the limit? Does it within the permissible limit? Pardon my handwriting, but you might have got what I'm trying to say. Anyone have got answer of A? Anyone? Very simple. This is meter per day. This is milligram per liter. Convert this one into meter, liter, or this one into meter cube. Milligram into kg. As it is asking for the kg, then multiply it. Then you will get kg per day. 5000 kg per day. Yes, correct answer is 5000 kg per day. Here you can see the flow rate was this thing. Flow rate was 10,000 meter cube per day. Okay now. So simply what was done, that 10,000 into 10 ki power 6, then it liter per day happens, into 500 milligram per liter it is, then it will be again 10 ki power minus 6 kg, uh, 10 ki power, it is milligram. Okay na? Oh then it will be, what it will be 10 to the power minus 6 kg per liter. Oh, it will be not 10 ki power 6, it will be 10 ki power 3, because 1 meter cube is equal to 10 ki power 3 liter. Okay now. So these 3, then it will be minus 3, this 2 it is completely gone, then 5 into 1000, that is 5000 kg per day, because this liter is also gone. Then correct answer is, how much BOD is removed? Remove is total BOD load into removal efficiency. How much BOD was get entering? 5000 into 90 divided by 100, that is 45. Okay na? So the second question was, second part was 4500. What will be the answer for the third part? BOD concentration in treated effluent after ASAP. See here from, here you can see that BOD remaining will be total BOD minus BOD removed. BOD remaining is 5000 milligram per liter minus 445. Then 5, this much is remaining. Okay now. So this much is going. It's like this is our water treatment plant, power plant. 50,000 is uh, mm, coming in, and going out is 500 kg per day. So remaining 4500 is here, that is being removed. Okay now. So now we have to convert, now see, remember this is 50 kg per day. Okay now. Sorry, 500 kg per day. Okay, now we have to convert into milligram per liter. So we will be using the we will be taking help of flow. Flow is constant, which we all know. Okay, so those values put here. Okay, now flow rate was 10,000, BOD remaining was 500 kg per day, and this thing, and finally the correct answer is 50 milligram per liter. Now the answer, fourth question was, is it good to throw this discharge this wastewater? Okay, so the answer will be strictly no, because the limit is 30 milligram per liter, but your treated plant is still sending 50 milligram per liter. So this won't be accepted. We have to set up different treatment plant with higher efficiency. Okay, now. So that's why question number 12. Another question is there. Take your time and try to solve it. Anyone got answer of first part? Same as the previous one. Here you will be, what we will be doing. First one will be 5,000 into 10 cube power 3 liter per day into 100 into 10 cube power minus 6 kg per liter. This liter gone. 10 cube power 3, this sunna, this 2 sunna gone, this 10 cube power minus 6 gone. Only we have 50 milligram per liter. Oh, sorry, not liter, kg. Sorry, my mistake. 500 kg. You can see here flow rate 5,000. There will be, where did I make mistake? 100. Oh, when it will be multiply, 600, it will be 500. Okay, now. ए बाबा, सिस्टम हैंग कर गया मेरा. Hmm. So, this will be 500 kg per day. Removed again. Same question is there, but only it was chromium. Now remember, still this is high. There will be, what is the limit? I don't remember the limit, but this is also high. Another question. So remember here, for treatment purpose they are using two continuous treatment. Okay, now so initially, say suppose 100 milligram per liter was going and its efficiency is 80%, then the finally will be 20 milligram per liter. And again, if it has efficiency of 80%, so what will happen, that the coming amount will be 4 milligram per liter, because all. Okay, got it. Okay, so inside we have, with the help of this continuous treatment plant, one having efficiency of 80%, another also having efficiency of 80%, we are able to convert this 100 milligram per liter to 4 milligram per liter. Okay, so the first question is total BOD load entering the treatment plant. BOD BOD load removed by anaerobic lagoon, the BOD concentration after the see what they are asking. Uh, First, what is the amount of BOD that is coming? Okay, okay now. So second is how much is being removed. So here it will be x, here it will be by. So they are asking for x minus by. Okay now. What will be the milligram per concentration after anaerobic lagoon? Now they are talking about remove. See, these three are related to anaerobic. Now, what is happening? The BOD load removed by aerated lagoon means how much now it is being passed to the second unit. How much has been removed? Okay, now final BOD concentration milligram per liter in treated effluent. We will be looking into one by one. Okay, now first thing is to for sure that flow rate into BOD concentration. Okay, so it is already 2400 kg per day. Okay, the BOD load removed again you will multiply it by efficiency that is 1680 kg per day. So BOD remaining will be 720, so BOD concentration will be 240 milligram per liter. So this was simple like if so first we have find out how much entering, how much has been removed, how much is remaining, then we have multiplied it by flow rate, then this much is going into the second unit that is aerated lagoon. Okay, now here the efficiency was saying that 85%, so this much is being removed. Okay, now so what will the final concentration? 720 was entering, this has been removed, so 10 kg per day, 108 kg per day we will multiply so final concentration is 36. The final, so he has in see like the wastewater has entered the treatment plant with having concentration 20 this much, how much 800 milligram per liter, but when it is leaving it is its concentration is this much 36 milligram per liter. Okay, question number 14. Again same type of question, again similarly to the previous one, but here they are using for chromium. Okay, now initially there is one plant which has efficiency of 92%, again there is one other plant which has efficiency of 70%. Okay, now the limit is written 45. So here remember in second numerical question I was asking that whether this we can discharge or not. So see in this question they have given some discharge unit. Now if discharge limit, so if your drinking water is below this limit, then not drinking water, sorry, uh, not drinking water, sorry, my mistake. I sometimes I get confused with this drinking water, wastewater. So if you are after treatment, if that limit is below the specified limit, then you cannot discharge, you have to treat it again. Okay, but if it is below this drinking water limit, then you can just discharge in again I have said drinking water, but again it is below this CPCB limit, then you can just discharge in the river and all these things. Okay, so these things are data. If you see the pattern is same. BOD load will be flow rate into BOD concentration divided by 100,000. Okay, now we have converted it to 2400 kg per day. Okay, so remove total BOD into removal efficiency. Removal efficiency is only 70%. So this much has been removed. That is 1680. BOD concentration. So what will be the remaining one? Remaining will be whatever the entering minus BOD removed. So 2400 has been removed. This much is sorry, this much is being removed. Then this much is being loaded. So remaining is 720 kg per day. Okay, now so BOD will be 240 milligram per liter. BOD load removed by aerated. Now see, initially something was coming. First it has been in anaerobic lagoon, then now it They are talking about aerated lagoon. Okay. Hmm. BOD load removal as it is has efficiency of 72% only. So 72, sorry, 85 only. Then whatever is coming from that side, uh, this minus this, sorry, whatever was coming from here, first this much was removed 90, then finally the concentration which is uh, coming out has only concentration of 108. So if you visualize it, consider this thing. How much milligram per liter was coming? 120 milligram per liter was coming. So 120 milligram per liter. How 120 milligram? 120 milligram per liter was entering. Huh. So this concentration after it is I don't know why it is 240. Okay, but you have got the gist. Okay, now whatever was coming first, first around 80% was removed. Then whatever is coming, what passed to say, another unit where there was some removal efficiency, say around 80%, and finally we get waste water, treated wastewater. Okay, so you can see BOD load is 720 720 108. 108 can be converted into milligram per liter with help of you, uh, with help of some you can just put it and you will finally get the answer as 36 milligram per liter. Anyone have any question in this thing? Anyone any question? See, all four numerical question were similar question. Okay, na, there was no such things very tough and all this thing. In last session, I can agree that there were some question which were challenging, but this time it was all very moderate level, moderate to low side. Anyone have any doubt? Okay, no, then just try to answer this question. We will be going very not in fast way, but these are some of the last question which you should know. Which of the following is a major environmental concern in the tannery industry? B. Yes, B. Hexavalent chromium is a toxic metal present in the chromium containing water, posing serious environmental and health risk. Remember, this question and the first question was very different. Here they are asking that which is responsible for the, but there was something else. What is the primary purpose of liming process in leather tanning? B. Only one people is participating. What about others? B. Removing a liming using calcium hydroxide and sodium sulfide to loosen hair follicles, remove fats, and often collagen fibers for tanning. Which tanning method uses plant? This is very simple. No need to discuss it. Why is ferrous sulfate not used in coagulant for vegetable? This thing already done. Remember A. Intensify the color of wastewater. Ferrous sulfate react with the tanning, darkening the color of vegetable tanning wastewater instead of removing pollutants. Which the following is mostly commonly used for BOD removal in tannery wastewater? Just try to answer this question by thinking that what is this BOD? BOD is why this BOD is due to high organic matter. So we have to look into the option where this organic matter are being removed. So does in sedimentation tank organic matter is removed? Anyone? The correct answer will be B only. Here because good. Good. Because all these are something else, something else. This is sedimentation to remove to remove what do I call? Um, Other thing, this is coagulation where we add chemicals to settle the suspended particles. Then we have filtration to bifurcate. But this activated sludge process is used for bacterial. What do I call? BOD removal. BOD removal means organic matter is are converted in that way. This BOD is also getting removed. What is the primary pollutant in pulp and paper mill industry? They are, all four are found. Generally, all four are found. But which is the primary pollutant? Anyone? B. B got one answer. B. Yes, the correct answer is B. The lignin and the organic compound. A byproduct of pulping gives high COD color to the paper mill element, making it major pollutant. Okay, good. Which pulping process is not most commonly used in paper industry? Which of the following process is most commonly used in the paper industry? Craft. Craft pulping uses sodium hydroxide and sodium sulfide to break down lignin, making the dominant published method due to its efficiency. Okay, so this is something else. The spent liquor produced during festival in craft pulping process is called. Let's don't take anyone. D. The correct answer is D. Black liquor is highly concentrated in lubricant chemicals and requiring resourceful recovery before disposal. Okay, so the I hope you are getting it why you have added D. It's not like that to come out. What is the primary purpose of massive lime treatment in pulp? This thing we have seen. Massive lime treatment. Anyone? B. Reduction of color in wastewater. The lime reacts with color absorbing lignin and color causing compound, improving the efficient quality. Which is the following system is used in aerobic digestion for treating pulp and paper, whatever. D. Have you answered? C. Yes, surface aerator. Surface aerator provide oxygen for microbial bioground. You can always search on the net what is this. What do I call? Uh, oh, see this type of things are there. Okay, na. In I think currently it is everywhere. Okay. Surface aerator provide oxygen for microbial and organic matter. Which of the following wastewater stream is most polluted in Tannery? Anyone? Again, see a different. The correct answer is A. Spent liquor, lime liquor. Spent lime liquor contains high alkalinity proteins, sulfide, and suspended solid, making it one of the most polluted wastewater stream. Okay, spent this thing we have discussed. Which biological treatment method is least effective for pulp and paper wastewater? Which biological treatment? Anyone? No. Trickling filter. I don't know. Trickling filter are prone to clogging due to fibrous, making them less effective in pulp and paper. These things are very cost effective. I hope you have heard of this trickling filter. So in activated sludge process, what they do, that there will be activated sludge, they will reintroduce. So whatever the wastewater coming will get activated bacteria. In trickling filter, this thing doesn't happen. There is a series of either material or column wastewater will be pass out. So if there is a proper interaction between these rock and wastewater, then water will trickle and finally we will get a treated water. But that is that is not so much effective. Okay, now so the correct answer will be B. On the other hand, these anaerobic and aerated lagoons are very effective. Okay, now because in aerated we have this supply of O2. The fish which has been given is seems to be hmm. So what happened that did you get it? Like what I was trying to say that. So what will happen that in aerated lagoon a sufficient amount of oxygen will be provided so that all the organic matter which is present there get sufficient amount of decomposition, means proper decomposition can happen. And you were saying about anaerobic lagoons. In anaerobic lagoons also this efficiency is very high. We have seen the different process of anaerobics. Okay, now this hydrolysis will be here. uh, Hydrolysis will be there. Then we have acid formation. Then we have acetone formation, yeah, formaldehyde formation, and finally methanogenesis. So these process happens here also. Okay, now so the least one is B. I hope you have got it. What is the pH range of combined pulp? This is a similar second question. Answer fast. B. Yes. Correct answer is B. Due to addition of these two, NaOH and N2S, the pH is high. Which is the advanced treatment method used for removing color from pulp mill effluent? D. No. The correct answer is O. Coagulation. See, remember, whenever you try to answer it, no, just try to imagine that where this has been used. Coagulation, what do? We add some kind of coagulant like alum, like ferrous. It will react with it will also, like, see, where this sedimentation is used. Sedimentation is used to remove suspended solid. Trickling filter is to remove organic matter. This coagulation, where this element is used to remove suspended particles which are cannot settle on their own. So these three cannot be your answer. Only thing is that, and also we are removing color. Color, for that we have learned that we need some kind of hydroxyl and all these things. This ozone, doing ozonation, a very this reactive material is introduced in the water, and that helps for the color removal. Did you get it what I am trying to say? Yes. This this ozone, you can hear ozone break down the leaching and organic pollutant, effectively reducing color and COD. Good. Which is the following pollutant removed using anaerobic? Now just imagine what is this anaerobic, how this is used, and all these things. Then answer it. Now, or you can go in opposite where the suspended solid are being removed. So suspended solid cannot be the answer because suspended solid are removed in no, sorry, B. The correct answer is again anaerobic thing is there. Anaerobic represents where this sulfate is chemical. Anaerobic represents oxidation of organic matter in absence of free oxygen. Your answer is incorrect, Nayagi. Because see this is related to microbial anaerobic bacteria and all this thing. So only the organic matter, so this BOD is only there, so this answer will be D, BOD. Heavy metals are removed not by some chemicals are added. This sulfate, for sulfate also some chemicals are added. Suspended solid, we know that with the help of gravity and all these things larger particle are removed. Did you get it? Yes, good. This is this thing you should know. Okay, na, but no need to memorize. But for no need to, you cannot memorize the specific. But just for your, I am from Kanpur and all this thing I have added. So as per CPCB, if there is one industry, wastewater industry is there. If it is whatever the amount of chromium is entering, the final concentration should be below 45 milligram per liter. Okay, now so the correct answer is C. Replenishment mass the total chromium to internally wastewater after primary treatment. Which of the following pollutant internally inhibit microbial activity in biological treatment? See, chromium is toxic. Here they are talking about, see, this other, this BOD suspended solid might not miss, what do I call, they might inhibit, but this presence of chromium is highly effective. Presence of just kill those microbes. Okay, now here you can see the chromium is toxic to microbes requiring pre-treatment before biological process. Okay, so the correct answer is B. Last question of the day. Which of the following cause foam formation in paper mill effluent? The B. The B is the correct answer. That's the resins and fatty acids. Resins and fatty acids are the reduced surface tension leading to the foam formation in the wastewater. So, so these are responsible for the cause of foam formation. If anyone have any more question, anyone? Anyone want to discuss any particular topic? Then I can discuss, or else. Anyone have any particular doubt? You can ask now, or else we can end the session. And again, see, I request every session. I request that please come up with like this time. This is for the first time. Sir, sulfates cannot be, but that is different things. Yes, sulfate. You are talking about that question. Just wait. See, this sulfate reducing bacteria is itself a. Yes, you are correct. That sulfate reducing bacteria will, but see, this sulfate redu. Just 1 minute. Let me share the screen. Okay, no, I'm not. Yeah, let me share the screen. Hmm. You might be able to see this. See this. What is they asking? Which of the following pollutant is removing anaerobic lagoons? Yes, you are correct that this sulfate bacteria, but sulfate reducing bacteria might not be always. How to? Yes, but see now you have to. Yes. Um, this is not a particular talking about. Here we are not talking particularly about see sulfate can be also reduce, but see this sulfate reducing bacteria acts in a different way. I don't recall it, but this conversion of sulfate to H2S. You in sewer pipeline we have seen this thing. This concept is used that sulfate by sulfate eating bacteria reduces sulfate to H2S, but that does not happen in this. Right now, I will say that this is not very specific. This is very specific. If you want to generalize thing, then we cannot just go on a particular pollutant and we will say that as it is reducing this sulfate, so this sulfate bacteria is reducing sulfate. So just wait 1 minute, let me think. Yes, yes, sulfate can be reduced by sulfate. Isn't it anaerobic? Yes, it is in anaerobic. But does your anaerobic lagoons contain sulfate reducing bacteria? The question is this thing. Do you know that your anaerobic lagoons contain this sulfate eating bacteria? See, you are correct. There is no question in your thought that yes, you are thinking it correctly. But the question is, does your anaerobic lagoons contain sulfate eating bacteria? You don't know, but for sure that as it is saying this anaerobic condition is there, Means there is anaerobic bacteria which will degrade our BOD. Okay, na? So that's why the answer was BOD. But for your argument, we don't know that whether your anaerobic lagoon contain any sulfate eating bacteria or not. Okay, na? So if there was something else question that is, then we could have thought of sulfate, but we are not sure about thing. And here we have to mark the most generalized and appropriate answer. Okay, good question. Any more question? No. Okay, then I will be ending the session. We have, if you have any question, you can type in or you can leave the meeting. I will. It's all on you. I think there is no question, so I will be ending the session. I'm ending the session with two requests. Please join the next session. First request, second session. If you are joining, please go through the lecture notes. Like this is the first time that only single boy, single, I don't know, girl or boy, has answered entire, was active in entire session. Only one student was active in the entire session. This is not good sign. So let's meet next week. Till that, tata. I'm ending the session.